Low industrial rumble. Back in 2022, during a routine factory audit, engineers discovered something surprising. Nearly 70% of a C-17's airframe begins as simple, flat aluminum sheets. But how do those sheets become a 265,000-pound aircraft capable of lifting armored vehicles and moving entire battalions across the world? Most of that transformation happens far from public view, inside restricted bays where precision meets raw industrial power. Today, we step inside those doors, from the very first cut of metal to the moment the F-117 engines roar alive for the very first time. Before we dive in, follow along and stay with us, because what you're about to see is one of the most complex manufacturing stories in American aerospace. The journey begins in the cutting bay, where approved metal sheets move into CNC machines that carve out the first structural pieces. Technicians check tool wear, alignment, and thickness before releasing each part. This early precision sets the tone for everything that follows, preventing structural issues later in the build. Ribs and spars for the wings take shape next. Each bend, each rivet, each drilled point is defined by digital standards that allow no room for error. These components will carry enormous loads during short field landings, and every test today ensures the aircraft can handle tomorrow's missions. The main spars are machined on a massive 5-axis equipment. Lasers track tiny deviations, ensuring the geometry stays true. Even a millimeter of distortion can affect wing performance, so every reading is logged, verified, and locked into the aircraft's lifetime record. With ribs and spars ready, the wing structure begins its assembly. Hydraulic jigs support the weight while technicians align each component. Temporary fasteners hold everything in place before the heavy rivets seal the structure. Strength tests confirm the wing is ready to support the aircraft's demands. flaps and slats move into production. Hydraulic actuators are attached, lubricated, and tested through full travel. These systems will help the C-17 land on short, rugged airfields around the world, a mission-critical capability verified long before the aircraft meets the sky. Inside the forward fuselage, conduits, brackets, and electrical routes are installed first. This section houses much of the aircraft's control logic, so every rail and cable path must be placed exactly right to support the cockpit systems that will come later. The mid-fuselage begins forming the cargo bay backbone. Reinforced rails are installed to handle heavy vehicles rolling in and out. These structures endure massive stresses during tactical operations, so technicians check torque and gap tolerances repeatedly. Cargo floor rails and tie-down points are positioned and tested under simulated loads. These fittings will secure tanks, helicopters, and palletized gear. Press tests confirm that the system will stay locked even under sudden maneuvers or hard landings. The rear fuselage takes form, home to the cargo ramp. Reinforcements, hinges, and hydraulic lines are installed in sequence. Each component is engineered to survive thousands of cycles during rapid loading operations around the globe. The forward, center, and aft fuselage sections are aligned for joining. Lasers measure curvature and twist, while the engineering team monitors every reading. If you've been following the build so far, stay with us. This is where the aircraft truly becomes whole. Heavy structural rivets lock the fuselage sections together. Sensors watch for microshifts as robots and technicians secure hundreds of fasteners. Each rivet reinforces the airframe's long-term strength, ensuring the C-17 can endure decades of hard service. Major electrical systems fall into place. Wiring harnesses are routed through predefined paths, keeping signal lines and power circuits isolated for reliability. Continuity tests confirm every connection before the next system moves aboard. Hydraulic lines are mounted across the aircraft. Rigid tubes handle primary loads. Flexible lines absorb movement. Pressure tests reveal any leak long before hydraulic fluid ever touches the system. Safety by design, tested again and again. Inside the wings, sealant is applied to fuel tank seams. Technicians work in tight spaces, spreading every bead with precision. Once sealed, the tanks are filled with test fluid to check for leaks. Only when every surface holds pressure does the wing move ahead. The completed wings meet the fuselage. Dual cranes lift each wing into position while engineers watch alignment readings. Guide pins lock the structure in place, and high-torque bolts finish the union. The C-17 finally takes on its true size. Landing gear installation begins. Massive assemblies slide into reinforced bays under the wings. Hydraulics, actuators, and wheels are installed in sequence. Extension tests check that the gear deploys cleanly, every time, under any condition. Inside the cockpit, the aircraft's brain takes shape. Panels, displays, and rudder pedals are mounted and wired. When the screens light up for the first time, the C-17 begins to feel alive, the control center ready for its future crew. In the cargo bay, roller tracks, tie-down rings, and lighting systems are installed. Everything is built for speed. Fast loading, fast unloading, fast response in crisis. The space is designed to support missions anywhere on Earth. The F-117 engines arrive after standalone testing. Technicians inspect every blade before the lift. Once mounted beneath the wings, fuel lines and sensors are connected. These engines will carry troops, supplies, and hope into places few aircraft can reach. At the rear, the towering vertical tail is positioned using synchronized cranes. Horizontal stabilizers follow, completing the C-17's iconic T-tail. This structure keeps the aircraft stable during slow approaches and heavy load operations. The aircraft faces its final checks. Ground crews inspect every panel, every wheel, and every control surface. Then the F-117 engines come alive, shaking the air as they spool to power. With the tests complete, the C-17 rolls forward, gathers speed, and rises into the sky. The moment when thousands of hours of work leave the ground and become America's newest airlifter.